Hello and welcome to another exciting episode. This is going to be about error handling in Rust. Rust is my favorite language, but it's not like the other languages, so sometimes it's a little bit confusing for beginners. But I think this episode is going to highlight a lot of cool things we can do with Rust. So first let's make our new project. We're going to call it error handling. And we're just going to go into error handling, and we're just going to start up there. So, there we go. Alrighty. Okay, cool. We've got a new Rust project. We're going to talk about error handling a little bit. So, what makes Rust such a fantastic language is that it's very hard to write code that will throw an error because the compiler handles a lot of the error processing. And I'll show you a little bit about what I mean by that. So the first thing we're going to do is open a file. So we're going to use the standard file system library, and we're going to use the file object from the standard file system library. So we can get rid of hello world, and we're going to make a new file, and we're going to call that a file open test.txt. Now, this does not return a file like what you might think. What it returns actually is a result. The result can either be a file or they can be an error. So if we wanted to actually return this and make this a file instead of a result, we would have a couple options here. So if we go and match it like this, we can match it to an OK result, in which case we want the file to be returned to file, and we have an error result. So if there's an error, we can panic and say error loading file like that. And let's see. Yeah. So what's it saying here? Whoops. Yeah. No semicolon. Okay, perfect. So now this is going to be a file. However, this can be a little bit verbose, let's say. If we're going to be writing in the main function, we don't necessarily want to write all the error handling here. We might want to take this error handling and write it elsewhere. But let me first write down another thing. So we've got a file. If we're going to try to open test.txt, if it finds a file test.txt, it'll open and return that file. If it doesn't, it'll return an error saying error loading file. So you'll see there's no test.txt file here. So let's run this now. It's going to come back with an error loading file. After it builds it, of course. Yes. So error loading file, system cannot find the file specified. Okay, and if we create a new file, test.txt, just put some info in it, try running this again, all good. It was able to finish because it was able to get the file. It does give us a warning though, saying that we're not doing anything with this file, which is a niche as far as Rust is concerned. So let's do something with this file. What we're going to do is we're going to create a new string, and we're going to make it a mutable string called buffer, like so. And then we are going to file read, maybe not hit random buttons, to string, to buffer. So we're going to put it into our buffer, like so. Now it's saying this is not loading, and it's because we have not loaded use state IO read. It gets this trait from the IO read trait, so we have to import that in. So, okay, we cannot borrow file as mutable because it has not been declared as mutable. Whoops. So there we go. All right, so this is going to also return a result, just like this. So we need to decide what to do with the error if there's an error. Well, if everything's okay, it doesn't really matter, so we don't have to return anything. But if there's an error, let's say, we can return, again, panicking, error reading file to string, and the error. Okay, all well and good. So we've read the file to a string, and now what we're going to do is we're going to see whether it's a number. So we're going to parse it to a number. And the reason I'm doing this, well, you'll see. We're doing a couple different kinds of error handlings just to show how long and convoluted a program can get until we start doing our cool error handling techniques. So, all right, let's parse this now. So we're going to do let the number equal, we're going to be, first we're going to, oh no, we can do it in parse anyways. So let's go buffer parse, and we're going to turbofish this to an I32, like so. And as well, we can see this is a result. So, and it's a parse int error, or an I32 is what's going to come out of it. So again, we're going to match this, and what are we going to match it to? Well, if it's okay and there's a number, we're going to return the number, and if it's an error and there's some error, we're going to panic and say error parsing file contents to number. Error, like that. Okay, so, whoops. Voila. Let's try running this again. What's going on here? Ah, yes. So, no, that's all good. Okay, so let's try running it again. It should run fine because we put a number in here. So 444. Let it compile. Compiling and compiling. There we go. So it was totally fine. But what if we change this to something that couldn't convert into a number, like dir? And we tried running it again. It's going to throw that. Error parsing file contents to number, invalid digit found in string. Okay, so why have I done all this? Well, we've got a few different errors to handle here, and I'm going to show you a cool way that we can actually do that. The first thing we're going to talk about is the shorthand for error processing. So instead of typing all this, we can actually just shorthand this to question mark. And what is question mark going to do? It's going to either return a file. Well, let's get rid of the match. So there we go. So it's either going to return a file. So see, it's a file, but it only returns, this can only be used in a function that returns a result or an option. So we have to actually return from main a result. And because main always returns nothing, it's either going to return nothing or it's going to return an error. So let's grab this error from the IO. And we'll call this as IO error. Okay, so if we do like that, type IO error in the scope. Oops, fix that little error there. Okay, and then we return nothing at the end like this. We now have a it now will work because this is going to either open the file or it won't open the file and it'll throw an IO error. Okay, pretty cool. So we can actually take this code and reduce it down to like this, file read to string, and we can add another question mark. So this is awesome, but you may notice this is not ideal because we're replacing our custom error handler, even though it essentially does the same thing but panicking. We're replacing it though with what is going to be a default error handler. So let's say this text.txt doesn't exist. It will still handle the error, but in a default manner. So build, compile, 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 and this system cannot find the file system specified, but it didn't handle it with our little custom string as before. It just throws the error. So that's good, but it's not perfect. And what happens if instead of matching this one, and you see why I did this, we throw another question mark? Well, it's going to highlight this because it's going to say could not convert into an IO error. because it's not an IO error, it's a parsing error. So that's all well and good. I'm going to show a couple ways we can handle this. First off, we can take this result and we can take this error and we can just use the standard error that exists, like so, except we don't know what kind of error it's going to be, so we can't throw it on the stack. We're going to have to make a box, and we're also going to have to make it a dynamic error. So if we do something like, whoops, we got to make a lifetime, whoops, no, that's right. Is that right? Okay. Okay, there we go. So, trait represented. Very good. So we're going to have to use dynamic. Okay, like so. There we go. So that's one way to deal with it. I don't know, my compiler's acting all funky. But anyways, if we make a dynamic error in a box, it can be any kind of error, which is great. But it also still is only using the default error handling. So why don't we actually look at a better way to do this using a beautiful thing called an enumeration. One of my favorite features in Rust. Oof, I'm so excited. Here we go. So, enum, and we're going to call it our R error. And the R error can either be an IO error, like so, or it can be a parse error. So let's get that loaded. So we'll have to load it up here. Num parse int error. Okay, like that. Awesome. And now we're actually going to pass this, instead of a dynamic box of errors, it's actually, we know which errors will possibly happen. So it doesn't have to be dynamic. It can just be one of these. But you can see now it's throwing an issue. Well, what is it throwing? It's saying there's nothing implemented for our error. So let's do a quick implementation. So we're going to implement from for our error, like so, from, and we're going to have from a IO error. Okay. And, oops. Okay. And we're going to return an R error, IO error. Let's see. Actually, it's like this, right? Okay. Oh, whoops. We gotta. There we go. Okay. Like so. My mistake. Oh, IO error. Gosh. Okay. Voila. Perfect. So, look at that now. This is now functioning with our IO error, and we can do the same from parse error for parse for our error. So, error is going to be a parse int error to self, and our error parse error, like so. And voila. Now, the only thing we have to do is use a decorator to derive a debug on this, and it should be good to go. Yep, there you see it. Now, the last thing we're going to do is actually make a type called rResult, and we can give it any type, and it's going to make a result with type T and our error in it. So we can replace all of our functions with an rResult instead of a result, like so. Now look how much smaller our main function has become. It's wonderful, and we can move all of this if we wanted to its own separate file, if we wanted to, an error handling file. So isn't that cool? And that's my video about Rust. I hope you enjoyed it.